Hi, 4th grade, it's Mrs. Boswell. Today we're going to do Module 5, Lesson 8. Okay? And we're going to continue on what we learned from Module 7, Decomposing Fractions with an Area Model. Remember, you can pause and stop the video at any time throughout, so you can re-watch what you might have missed. So, we're going to continue decomposing fractions with an area model and multiplication. Mine are going to be found on pages 33 and 34. All right, here we go. So I'm gonna line it up for you. All right. So we are doing Module 5, Lesson 8. We're doing equivalent fractions with multiplication and the area model. Okay? Our statement says, and what we're going to learn by the end of this lesson is, I can use the area model and multiplication to show equivalent fractions. Okay? We're just going to review what you did yesterday. We're going to take that same thing. Remember, when we are doing fractions, on the top, you have the numerator, and on the bottom you have the denominator. It says to find an equivalent fraction, you're going to multiply the numerator, so that n, and the denominator by the same digit. So whatever I multiply the numerator by, I have to do the same with the denominator. Okay? So here you have an area model. And our directions say, shade and record 2/3 in the area model. Okay, well, that can be pretty easy. So I need 2/3. I know this is broken down into thirds. 1/3, 2/3, 3/3. How many do I need to shade in? Just 2. So there's 1, 2. Okay? Now the next step of our directions say, now draw 3 horizontal lines across the area model. Remember, horizontal lines go across from side to side. So I'm going to get a different color marker so I can kind of keep this separated. And it says draw 3 horizontal lines. So I've got 1, 2, and 3. Okay. Now, before I drew the horizontal lines, I had an area model that was 2/3. What happened now to the size of my fractional units? What do you notice? Am I still showing 2/3 now that I've divided it? If you said no, you're right. I don't have 2/3 anymore once I've added those 4 lines. Now, if I took out those 4 lines and I kind of covered them up, right, I have 2/3, right? So what happened to my fractional unit? Okay, well, let's see. How many did I break it down into here? It's 1, 2, 3, 4. Oh, we broke it down into 4 smaller units. This is into 4 smaller units, and this one is into 4 smaller units. It says the units are 4 times as small because we divided each unit into 4 smaller parts. Okay? Or I multiplied it. I'm sorry, I didn't divide it. I multiplied it into 4 smaller parts. Okay? Now it says, what happened to the number of units? Okay? Well, before my units, I had 3, right? 1, 2, 3. How many units are there now? Well, let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I have 12 units. So there are 4 times as many units as there was before. Okay, so the first I had 3, right? Well then, I made them into 4 smaller units, right? And 3 times 4 is, guess what, everybody? It's 12. Okay, So when I multiplied those and I added those 4 units, because I wanted to break it down into more people, right? So first I could only break it into 3. Like I could only split that candy bar into 3 people. But now how many people could I could hand that candy bar out to? Since I multiplied it, right? I put it into 4 more smaller units. I got 12. Now I can share that with 12 different people. Okay? Now it says, what happened to the selected or shaded part of the units? Okay, so let's look at my units. It used to be 2/3, right? Or 2 out of 3, right? Was colored, was shaded in, right? 2 of those were, right? But I multiplied it by what? By 4. And what did I get? I got 8. Okay, so what's the shaded part now? The units became 8 because I multiplied it by 4. Okay, so now I could show you this, right? I'm going to kind of scribble this one out, and I really should have done it like this because my 3, right, was at the bottom. Okay, all I would have to do, 4th grade, watch this. Ah, look, 2/3 times 4 equals 8/12. Could I show that down here? Yeah, look, 2/3 is equal to 2 times, well, what did we shade the selected unit by? We multiplied it by 1, 2, 3, 4, right? And what did we multiply the denominator by? Well, let's see. 1, 2, 3, 4, right? By 4. So 2 times 4 is 8. 3 times 4 is 12. Okay? So 4th grade, is this an equivalent fraction? Is 2/3 equal to 8/12? Did my area model change? Did I add on another unit over here? Nope. All I did was I actually multiplied the units. When I broke it down with those 3 lines, I added 4 additional things to it. 4 additional to the numerator and then 4 to the denominator. So 2/3 is equivalent to 8/12. So we're going to say yes. Those are equivalent fractions. So let's talk about these questions over here again. It says, what happened to the size of the fractional units? They became 4 smaller units. Should start that with a capital letter. Okay. What happened to the number of units in the whole? Right? Well, the whole was multiplied by what? By 4. Okay, what happened to the shaded number of units? Okay, so that whole is the same as my denominator, right? Denominator, right? And the shaded number is my numerator. Well, what did I do? I multiplied it by 4, right? So I took that denominator, my whole, that 3, and I multiplied it by 4. I took my numerator and I multiplied it by 4. Okay? And when I multiplied it, I got 8/12. So did I get more units or less units? We have more units. More units. More units. Okay, that's important to know. When we multiply, we're going to get more units. Okay, but what I know is that my units are what? They're smaller. Okay, so as you take a fraction, right, and you multiply it, your units get, the numbers get bigger, but my size of them get what? They get smaller, right? Because before, here was my 2/3, right? This was into 3, 2/3, right? That was my original problem. But we broke it down into 4, right? We didn't break it down. We divided it by 4, right? To make more units, okay? And my units became 8/12. So how do you know the fraction is still representing the same amount? Well, because I didn't change the size of my area model. We didn't change the size of the area model. It stayed exactly the same. All we did was we divided it into 4 parts. Okay. Did I change how much was selected? Nope. Okay. There are just more smaller units instead of fewer big units, but the area of the shaded fraction is still the same. So our fractions 2/3 is equivalent to 8/12. Okay. All right. Let's go ahead and turn on to our next page. And we're going to go ahead and continue this problem. So remember, we're working with the area model and multiplication to show equivalent fractions. Remember, equivalent fractions, okay, are equal to each other. Okay. Here we go. So it says find an equivalent fraction for the original area model. So here's my original area model. What's my denominator? What's my whole? 1, 2, 3, 4, 5, 6. Okay, so that's down here. There's my whole. Okay. What was the shaded part? 1, 2, 3, 4, 5. Oh, there's my numerator. That's 5, 6, right? I want to see, is 5, 6 equal to 12? And this has a question mark here. We don't know what that is. We have to figure out what is this. Well, I could do this pretty simply. Okay. 6 times what is going to give me 12? Okay. Well, remember back over here where we drew the lines? We drew those horizontal lines. That's exactly what we're going to do on this area model so that we can make more units, but that are smaller, right? Okay, so 6 times what would give me 12? Ooh, I know that 6 times 2 is going to give me 12. So how many lines would I need to do for 12? Okay. Oh, here's 1 part, 2 parts. Oh, let's see if I get, is 6 times 2 12? Let's see if I have 12 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, does that match? Oh, so then what would be 5 times what gives me what? Well, all I have to do is count my shaded parts, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, there's 10. Ooh. Let's go back over here to this reference right here. It says, to find an equivalent fraction, you multiply the numerator and the denominator by the same digit. Oh, well, let's see. Here's my denominator, and I multiplied it by 2. So what am I going to multiply that numerator by? If you said 2, you're correct. So 5 times 2, does that equal 10? Yes, it does. So is 5, 6 equal to 10/12? Yes. Okay. Is it an equivalent fraction? Yes. And we're going to be asking, are these equivalent fractions? Okay, let's look at our next one. 5, 6 equals, blank times blank, blank times blank equals 15/9. Huh. Well, I need 6 to go into 9. So I know, so let's see. Let's make sure we have this, our whole. Our whole should be 6. 1, 2, 3, 4, 5, 6. Oh, so I'm going to put 6 because there's my whole. 6 is my whole, right? So I want to carry that over, okay? And then 5 is my shaded part. 1, 2, 3, 4, 5. Yep, that's 5. Okay, so that's my numerator. So I got 5, 6 times what? 6 times what gives me 9? Ooh, that's really hard. I don't really know. Maybe it's 2. Maybe I'll draw a line 2. Let's see if I get a total of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh. I can't even divide it. I can't even multiply it by, I can't even multiply it by 2. Okay? And I can't even multiply it by 1 because 6 times 1 is 6. So is 5 6 equivalent to 15 ninths? I can already say what? No, it is not. Why is it not? Because 6 times the same number is not going to give me 9. But let's look up here. 5 times what would give me 15? Ooh, 3. Ooh, so maybe I should divide this into 3. Let's change that up. 1. Look, 1, 2, 3. I multiplied it by 3. Ooh, let's see if I get 15 shaded parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Ooh, this top part works perfect. So if going back to that same thing, to find an equivalent fraction, I have to multiply the numerator and the denominator by the same number. Ooh, so maybe it should be by 3. 6 times 3. Okay, well, let's find out what's my whole. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Ooh, 18. Oh, so really, I know that 6 times 3 is not going to give me 9. It's actually 18. So this is 5 6 is not equal to 15 ninths because they're not equivalent. But I could re-show it over here as 5 6 is equivalent to 15. What did we say? What was that denominator? It should have been 18ths. Okay, so I could correct it over here, but this 15 ninths is not an equivalent fraction. And so 4th grade, you're going to get some examples today that are showing equivalent fractions and ones that will not show you. So let's do 2 more problems together before you get started. It says find an equivalent fraction without drawing an area model first. Okay, well, I'm going to go back to this saying again, right? Sorry. To find an equivalent fraction, multiply the numerator and denominator by the same digit. Okay, so let's do that. So we have 3/5, right? So I'm going to take 3/5 equals, and I'm going to multiply it. I'm going to put that line in the middle. So I'm going to take 3/5 times, and it says I have to use the same number. So let's say I'm going to do, let's multiply it by, let's just do 3, right? Okay, let's see if I can find an equivalent fraction. So 3 times 3 is 9. 5 times 3 is 15. Okay, so now I think that 3/5 is equal to 9/15. I think that's equivalent fraction because I took the numerator and the denominator and I multiplied it by the same number and I got 9/15. Let's see if I can do that with an area model to see if I'm correct. So first I need to show an area model of 3/5. So I'm going to show an area model and I'm going to, what's my whole? My whole is 5. So I've got 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. And I'm supposed to color in 3/5, right? So there's 3/5. Now, I multiplied it by what? 4th grade. I multiplied it by 3. So I have to have, I'm going to multiply it by 3 equal parts. So I'm going to add those lines. So I've got 1, 2, 3. Did I do that? Now let's see if I get the same numbers. My shaded part should show 9 and my whole should show 15. So let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, this part matches, so that works. But now I have to find the whole. What is my whole? Let's see if it's 15. So I've got, I already know that's 9, 10, 11, 12, 13, 14, 15. Does it match up? Yes, it does. 3/5 is equal to 9/15. Now, could I multiply both of the numerator and the denominator by 2? Yep, I could have. And I would have gotten the same. I would have not gotten 9/15. Okay, I would have gotten 6/10, right? If I would have divided that. So I could show you that again. Would 3/5 equal times 2 times 2, right? does it equal 6/10? Well, let's just do it. Here's another same area model, right? 1, 2, 3, 4, 5. Okay, color in that 3. And this time I'm only going to multiply it by 2, so I should only have 2 equal parts. 1, 2. Okay, let's see if I get 6/10. 1, 2, 3, 4, 5, 6. Ooh. 6, 7, 8, 9, 10. Ooh. Oh, is this another equivalent fraction to 3/5? Yeah, 3/5 is equivalent to 6/10, or 3/5 is equivalent to 9/15, because we multiplied it by the same number. Okay, we're going to do 2/4, and we're going to show another way. So I'm going to do 2/4 is equal to what? And we'll find out. So we're going to take 2/4, and we're going to multiply it by the same number. Let's do 4 this time. Let's multiply it by 4. I'm going to do both of them by the same number, right? Because I would have to get the equivalent fraction. So 2 times 4 is 8, and then 4 times 4 is 16. So when I draw my area model, I'm first going to represent 2/4, okay? And then I'm going to show 8/16, right? So 2/4. So I'm going to take my area model, and I need fourths. 1, 2, 3, 4, right? And then 2. 1, 2. And then this time, I multiplied it by 4. So I'm going to put in multiply it by 4 equal parts. 1, 2, 3, 4. Ah. So I got 1, 2, 3, 4. Ah. Let's see if that matches. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, it does. 9, 10, 11, 12, 13, 14, 15, 16. Ooh, there's my whole, my numerator and my denominator. Is 2/4 equal to 8/16? Yes. Okay. Did I change my area model? Nope. That units, okay, it was still 4 whole parts and 2 shaded, 2/4 is still the same as 8/16. Okay. 4th grade, it says, I can use the area model and multiplication to show equivalent fractions, and that's exactly what we did today, and you'll be doing more on your problem set. Good luck today!